At first look, this may look like sensationalism, something just to capture your attention, because you may never have thought that tillage could be bad for soil. But let's take a few minutes to look at this. These soils are taken from the Texas High Plains near Bushland, Texas, on a research station that was studying the effect of tillage on soil. Actually, it's kind of the reverse of that. The one on your left is the system that all of these sites had been in for about 100 years, maybe not quite that much. And prior to this, the system was changed about 20 years earlier than this to a no-till system on the very far right and to a conservation or stubble mulch tillage system in the center. So on the left, used a traditional inversion tillage method. In that case, it was usually a disc plow or a tandem disc plow where they were stirring and burying all the residue, cutting it up and putting it into the soil. Tillage would also be used for weed control with some other implements. So the soil was continually tilled, and you can see that the color is much lighter and the structure is much less evident. These soils were taken within 30 meters from one another, so about 100 feet. They are all clay loam soils from the same soil series. Now the one in the center, they changed to a stubble mulch tillage system, which meant they used a blade plow which undercut the soil but left most of the residue on the surface. And then on the right-hand side, you see the one that's been in a no-till system. You see the color gradient. That color gradient tells us something about organic matter. So tillage burns up organic matter. The more you till, the less organic matter you have in the soil. Why? It's about biological activity and sheltered organic material. So when you plow a soil, it's like stirring a fire. You break open aggregates. You expose essentially a buffet for the microorganisms, and they'll eat all the carbon that they can find. When you stop tilling as much, you stop disturbing the soil as much, you stop breaking open as many buffets, and you begin to store some of that carbon back. And then when you stop tilling essentially altogether, other than just the disturbance to plant a new crop, you have a tremendous increase in organic carbon. So you can see that gradient, and you can see the gradient in structure from something that's got very poor, weak, subangular blocky, and even some that looks almost single grain, to something that's got moderate and weak subangular blocky, to on the very right-hand side, some moderate subangular blocky and even moderate granular structure. So what did tillage do? Destroyed surface soil structure and burned up organic carbon. Is tillage bad for soil? It certainly can be. Well, let's look at a different series. In this case, we're looking at central Illinois soils. You see a color gradient, so let's talk about that gradient. This one is one of the 0.1% of the tall grass prairie that's never been plowed. You can see beautiful granular structure, even some crumb structure, which are like larger granular aggregates. Don't see any subangular blocky aggregates in there, and the color is nice and dark. The next one on the other end is the one that's been subject to the greatest amount of tillage for more than 130 years, probably, maybe as much as 150 years, using a conventional inversion tillage method, where again they buried all the residues. In this case, probably using a moldboard plow, especially initially, and then using disc plows or other types of plows that continually stirred the soil. Used also those plows for weed control, continually stirring, turning in all the organic residues that were left on the surface, decomposition, opening up that buffet, and the lighter color shows you that carbon has been going out of it. Now the other thing that you can see is this. Need to turn that one over to really experience it, but this is the surface crust. You can see that it's a few millimeters thick. Rainfall events destroyed what little weak structure was there. particles fell apart, or aggregates fell apart, individual particles, and then they collected on the surface and formed a crust that will later limit water movement into it. Now, what happens next? Well, this one they took out of crop production about 5 years prior to this picture and put it into permanent grass, so it's begun to recover. You can see a difference in the structure, and the color's gotten darker. And then this one has about 12 years prior to this was put into a no-till system. What's affected then? Well, root growth and aeration. You can see roots through this one. You can see lots of nice pores that water and air can move through. Not so much here. You can see that the structure is beginning to improve as we go through this gradient. We like to find the granular structure in the root zone, but again, it's been lost in these that have been plowed. So why do people till? Well, historically, tillage is about seedbed preparation and about incorporation of residues and weed control. I mentioned those two of those three things already, but seedbed preparation, you want a good spot to be able to put the seed so it makes good contact with the soil so it can imbibe water and then begin its process of germination and growth. Incorporating residues, things that are left on the soil surface, incorporating them in. What we've learned in the last 50 years or so is that's not necessarily a good thing. The old idea was that you mix them in. During the decomposition, it releases residues, or releases nutrients, and that's good for the plants. But overall, you burn up that carbon, you reduce the size of the pool when you start incorporating all those residues. Now, in the last 40 to 70 years, they've got some other ideas that they've put in for tilling soils, and in this region, one of the reasons they do it is to dry that soil, introduce some oxygen because you're in very humid region, moist soils, and in the early spring, when you want to get in and start planting or work the field, wet soils dry more slowly, or wet soils warm up more slowly, obviously, they dry more slowly, and so if you can dry the soil a little bit more, that adds oxygen for plants to grow. It also allows the soil to warm more rapidly. And as you move further west, what you end up with is the need to conserve water. So you leave residues on the surface to limit evaporation and try to put water in there. We also are thinking about how we leave residues on the surface so we can minimize erosion. So soil conservation, residue management for water conservation, warming, these are newer reasons that people are using tillage.